Hello, my name is Christiane Keaton, and I'll be providing the introduction to our project, an analysis of drug-related crimes in abandoned buildings in the city of Chicago. Vacant, unsecured buildings litter Chicago neighborhoods, providing havens for squatters and illegal activity such as drug possession, drug dealing, and manufacturing. Crime is festering as more buildings become empty due to foreclosures. Last year, more than 2,600 crimes were reported in Chicago's abandoned buildings and vacant lots. That equates to an average of 7 crimes per day. Innovative information technologies are playing a key role in improving law enforcement's ability to anticipate events and respond appropriately. Predictive analysis is one of these technologies. This project aims to assist the Chicago Police Department by identifying the areas where abandoned buildings have been providing a haven for illegal drug activity. Our intention is to provide the information obtained from the analysis of drug-related arrests over the course of the last 11 years in relation to abandoned buildings through analyzing the City of Chicago crime area data set. We will provide the information to the Chicago Police Department in an effort to empower them with the knowledge they require to determine the appropriate actions and allocations required to minimize these illicit activities in an effort to take a strain off their limited resources. By identifying within the data the community areas where the rise and occurrence of illegal drug activity occurs, it will provide information which will determine whether the abandoned buildings in those areas are the cause for the increase in these arrests. For a vision versus final product, we believed originally that manufacturing would result in higher crime rates in abandoned buildings. However, what we determined was possession and distribution actually equated to a higher number of arrests. We thought we would be able to give direct recommendations to the City of Chicago Police Department for alleviating these high numbers. However, our data was insufficient in providing a direct response. Going forward on this project, we would recommend a specific drug analysis on heroin as it had the highest growth rate. For our lessons learned, a few items which we learned in the process was first, we should have merged the data sets after cleaning rather than before. As we merged them all first, it was very difficult to clean the data and we had to begin again. Our second lesson learned was to check for an interaction between predictors before the model selection process, because interaction can result in some very important models to be excluded. Our final lesson learned was correlation doesn't imply cause and effect. For example, unemployment is highly correlated to the number of abandoned buildings. We cannot say unemployment causes the high number of abandoned buildings. And now for Sharat with the ETL process.
Thank you, Christian. I'm Sharadvi Fashi, and I'll be dealing with the ETL process and data exploration analysis part. To start with, we downloaded the data from the City of Chicago website, and the link is over the screen. Next, we downloaded 3-4 datasets from the website. Initially, we downloaded only the crimes 2001 to present dataset from the City of Chicago website, and according to our objective, we filtered the datasets for narcotics crime, which were occurring in the abandoned buildings. This is the initial dataset, and it looked something like this one in screen. Next, for the data consolidation, there were some problems with the data set we downloaded. The main one was there was no variable to assign the cause and effect relationship, and also there were no specific target variables. So we explored the website for more to dig for some more data, and we found out that the socioeconomic indicators, abandoned buildings, and police station websites data sets were available, and we downloaded them. For the data cleaning part, we used VLOOKUP extensively in the entire process, and first of all we checked for the range of each and every variable and checked for outliers and any missing values. For example, for 100 missing values were there for the community areas. First of all, we thought that we'll go ahead and directly delete them, but later we found that there could be some consequences if we directly go ahead and delete. So what we did was we had the location of these crimes for the missing community areas, and to figure it out, we checked the heat map of these crimes and checked if these missing values were from a particular district or a police zone, and we found out that all these missing values were quite distributed, and that's why we went ahead and deleted these values. Next, coming to the data transformation, there were some problems with some of the variables like date and time field and latitude and longitude field. These two columns were initially the same column with these date and time in the same column. So what we did was we divided these columns into the different columns, one for the data, one for the date, and one for the time. Also, we divided the dataset into 5 different zones based on the police districts. And we wrote a formula for calculating the average number of vacant buildings in each district and the distance of the crime from the nearest police station. For dividing the datasets, we use this graph, and based on the police districts, we divided our dataset. And for the data reduction part, since we downloaded the data from the main dataset, that is the crimes 2001 to present, and the columns location, description, and primary type were effectively the same, and this made no sense. That's why we went ahead and deleted these two columns for as data reduction part. Now for the in data analysis and exploratory analysis, what we found out that the total of all the total crimes occurring in abandoned buildings, zone 5 contributed in zone 5 42% were narcotics related, and it's a big number that we should look out for. Also, hardship index, per capita income, and unemployment rates play a very major role in the number of crimes. For example, in zone 3, which has the lowest hardship income index and also the highest per capita income, contributes very less to the number of crimes, and also it has a lowest unemployment rate of 7%, whereas in zone 5 the hardship index is very high, that is around 70%, and the per capita income is also quite low, and the unemployment rate is also quite low, and uh, consequently the number of crimes in zone 5 is relatively high. Talking about the frequency of heroin, zone 4 has the highest frequency of heroin, whereas the other in other zones marijuana prevails a lot. And another interesting thing which we found out was in the year 2008, since the year 2008, there is a steep increase in the number of crimes, which we may attribute because of the economic crisis. And interestingly, after 2012, for each drug, we saw a drop in the number of crimes. Now we will go ahead and talk about something about the data models, which Aniket will be taking you all through. Thank you.
Thank you, Sharat. Hi, I'm Aniket, and what I'm going to talk about is the model building process. I'm going to talk about all the steps that we went through to come to a final model for our data set. Okay. Okay, the first step here, in the first step, we divided our data into two parts, the training and the testing data. The purpose of the training data is to train our model, or to create a model using this part of the data, and the purpose of the testing data is to to use the already created model to score it and check and evaluate the results that we have. So for this we tried different ratios like 60-40 we tried 70-30 and 80-20, 90-10 and all the kinds. But depending on the size of our data, we found that 80-20 is the best suitable option for this. So we went ahead and used the 80-20 data. Also we used the seed of 1 2 3 4 5 6 7 to so that we all have the same sample, but we didn't actually need it. Okay. The model build. The whole process of model building is based on three different steps, three parts. We are going to discuss each of these steps one by one in detail. The first one was selecting target variable. Here we selected our target variable depending on the data set and the output that we needed. The second is the selecting predictors. What are the important predictors that we need? And the third one is selecting different models out of the different models that we ran. Okay, so the first step here I'm going to discuss is the target variable. Now we had a data set with around 37 columns, yes, but there was no particular column or a combination of column that could actually serve as our target variable, and that we could actually take there directly, and that would give us a fair result. So we had to create a new target variable. For example, we had a column called the number of abandoned cities. I'm sorry, the number of abandoned buildings in a particular community area. But we earlier thought that we could select this as our target variable, but then we realized that this wouldn't give us a justifiable result, because depending on the size of the community area, the number of abandoned buildings in a particular community would change, and hence the result would not be fair. So taking these kind of things into consideration, we went ahead and created a ratio. And we actually named it as our target variable. So the ratio is the number of narcotic crimes or drug-related crimes committed in an abandoned building within a particular area upon the total number of all kind of crimes committed in an abandoned building in that particular community area. So selecting this target variable has a benefit that is it takes into account the number of abandoned buildings in a particular community area. So the number of abandoned buildings, so the difference in the abandoned buildings in community areas doesn't really matter anymore. So this ratio that is our target variable. Okay. The second is the predictor selection. As I said, we had around 37 columns. That means 37 possible predictors. We didn't really want to complicate our analysis so much, so we decided that we would just select like four or five most important predictors for our model. So for this, we ran the feature selection module within the IBM SPSS modular. What this module does is it ranks different predictors based on the importance it has on your response variable, that is the target variable. So the output that here I have pasted shows the rank of these particular variables. So the first one is zone and the last one is percentage age 16 plus and unemployed. So taking these top 4 or 5 variables, we see that the first is zone and the fourth is community area. Now we cannot really use zone or community area as our predictor because these are just numbers that we have assigned and that we have talked earlier. It's just based on a map, so it doesn't really affects our analysis and it's not really relevant to our analysis. So we left zone and community area. So we went ahead and selected percent of housing crowded, per capita income, and yes, the other one is the hardship index. Now we try to run our analysis taking the hardship index as our variable, and the result was pretty good. But then what I suspected was that hardship index is nothing but a combination of different variables like percentage of housing crowded, the poverty in that particular area, the unemployment. It's all it's the combination of all other variables that is already in our data. So if we take hardship index on the account, then it would not be a fair result because the there would be an interaction effect of different variables. So we ran our some analysis and descriptive analysis for this hardship index variable. So the results were something like this. When we plotted a scatter plot for hardship index and poverty, the highlighted area shows how correlated it is. For example, here the correlation is 0.79, which is pretty high. Similarly, with the other variable of housing crowded, the correlation is still pretty high at 0.5. So we decided to exclude the hardship index variable, although it was giving a very good result. So well, after excluding hardship index uh, from our analysis, we were left with four final predictors that were percentage age 16 plus unemployment, per capita income, distance from police station, and percent housing crowded. These are the four most important variables that we had. Okay, so after we have our four most important predictors, the next step is selecting the models. We ran different models based on their importance. For this, we use the auto classifier node that is available in the IBM SPS modeler. What it does, it ranks different models and gives us the top 3 or top 5 as we choose top 5 models, and we could go ahead and test different models using that. So what we did was we selected 3 different models for our uh, analysis. The first one was shade, and the second one was classification and regression tree, and the third was the neural net. These 3 models we chose for our analysis. Okay, the first one is shade. Now the predictor importance, when we first ran the shade model, the predictor importance was for 2 variables was not generated for the distance between police station and the unemployment. The predictor importance was not generated for because of this. What I did was I generated a accuracy boosting ensemble so that we have a better accuracy, and After running this model, we had the predictor importance for those two variables, and the overall accuracy of the model was 95.7%. So this is how the predictor importance of in shade looks like. The housing crowded has the maximum importance, whereas the 16 plus unemployment has the least importance. The second model that we ran was the classification and regression tree. It has two parts, as the name suggests, the classification and regression. Our analysis was the regression type problem because our analysis, our response variable is continuous. In case we have the response variable is categorical, then it would be under classification type problem. What CNR tree does is it drills down the leaf node till it is further unclassifiable, and then it stops. The overall accuracy of the CNR tree was found to be 94.1%. Similar to the chain model, the housing crowded has the maximum predictor importance, and 16 plus unemployed has zero importance. So this is the typical output that we see when we run a classification and regression tree. It is a tree. For example, if we take a particular instance of this, if the percentage of housing crowded is greater than 4.750 and percentage age 16 plus unemployed is less than 17.20, the final target variable would be 0.112. So this is how the output of the CNR tree look like. The third model that we ran was neural net. This is how a simple neural net looks like, with 4 different inputs and an output layer, which is our response variable. But we created a multi-layer feed-forward network. What the difference is it has an additional hidden layer. So all the inputs have different weights for each of these hidden layers, and a hidden layer uses a non-linear function to give out a particular output. The number of hidden layer, by the way, is assigned before the analysis is started. So we use the feed forward network. The final weighted graph of our analysis looked like this. It had four different variables on the left side, which were connected to 7 neurons, or the hidden neurons, for different weights. Different color of these lines shows different weights for each of the variables. The accuracy of the overall model was 93.1%. Now, after we ran different models, what we needed to do was assess the strengths and weaknesses of all the models. For example, Shade is really good to visualize the relationship between target variables, and the tree that it generates can be easily summarized. But both Shade and CNR tree work really good for the large quantities of the data, but our data was not very large. Similarly, the CNR tree. The problem with both Shade and CNR tree is they are really good to visualize, but they are really hard to explain to the real business situations. Neural net. The benefit of using a neural net is that it has the ability to learn on itself. It has auto learning capability, but the problem is that it is a black box, and the actual working of it, the nonlinear function that it uses is actually very hard to understand, and it makes it very complex. So all these models have their pros and cons. The final model comparison and assessment was based on 3 different parameters. The first one was the overall accuracy, the second one was the predictor importance that it generated, and the third was the output analysis, the output that it generated. For the first one, the overall accuracy, all the 3 models had more than 90% accuracy. So all these 3 models were good, but we know that we cannot just go ahead and select the model with the highest overall accuracy. That would not be fair. So the second one was the predictor importance. Almost in all the variables that we had, housing crowded is the most important variable, but the difference was in the weight of different variables. So if we consider the predictor importance alone, neural net definitely has an edge because uh, uh, in uh, in CNR tree, as we looked earlier, the distance of police station from a crime spot is not given any importance. But we in our from our exploratory analysis, we knew that the distance of PS was significant. It cannot be zero. So we excluded CNR tree from our consideration. Similarly, in shade, the housing, the poverty was given very high importance, but all the other variables were significantly less. Although there has to be difference, all the difference between the importance of variables, but the difference was very high in the case of shade. So we had to exclude shade also from our consideration. So if we just look at predictor importance, neural net definitely has an edge. The second one is the output analysis. Now, the shade is an algorithm that generates relationship between target variables and predictor variables, and in the form of tree image. But the problem with shade is it works only on large data set. But we had only like 2,500 records, so we cannot really trust the result that shade gives us. Similarly, with this, the classification and regression tree, on the basis CNR tree, what it does is it just divides the data set into two subgroups or trees. So the you cannot really trust the dependability of CNR tree because it, like shade, it also works on large data sets. Uh, so now neural network are black box. That is, the knowledge of its working is never clear. Its process is also just an approximate of desired results. Although the process is just an approximation, the result neural net produces is uh, fairly robust. So output, considering these three parameters: overall accuracy, predictor importance, and output analysis, we found that neural net is the best bet that we could have. So our final model was neural net with the accuracy of 93.1%. So thank you. Piyush is going to take over from here with our final model, and he's going to present the conclusion and recommendations that we have. Thank you.
Thank you, Aniket. I am Piyush and I am going to discuss the conclusion and recommendations of our project. Starting with the conclusions, first I'm going to talk about objectives that we have fulfilled. In the first place, our objective was to determine the abandoned crimes in abandoned buildings, specifically narcotics crime, and we have successfully analyzed it and determined the factors which lead to such crimes. We have also identified the various areas where the crimes are most prevalent. Next is our data preparation and software used. We have prepared a dataset from the three datasets available from the City of Chicago website. We have defined our own target variable because we didn't find any target variable which suited our needs. So we have defined our target variable as the number of narcotics crimes which occur in abandoned buildings and the number of crimes which occur in abandoned buildings without the specificity of narcotics. The next are the softwares that we have used in our project. We have used Microsoft Excel for data preparation, SAS for descriptive statistics, and then we have used Tableau to do some exploratory analysis, and then we have used IBM SPSS Modeler to build our models. Then is the step of model building and final model making. We have created three models: CAD, CNR tree, and neural network. We have chosen our own defined target variable as the target variable, and we have found that all the models gave us a very good accuracy of over more than 90%. We analyzed and compared these models based on various factors and found that the neural network is the best model for this scenario because it gives the more appropriate importance to each of the factors. Next, I'm going to talk about our recommendations that we have reached from making of our project, which we can suggest to the City of Chicago and the City of Chicago Police. First is focusing on heroin in zone 4. As we can see, in zone 4, the most drug crime which is occurring is of heroin. In other zones, we have found that marijuana is the most prevalent drug. But as some states in the US have made marijuana legal, so heroin is the drug which should be concentrated more. Hence, in zone 4, there should be more concentration and monitoring because it is more prevalent to heroin. Next is the effect of crowded housing. In our model building phase, we have found that the effect of crowded housing is the most important predictor, and so we ran a exploratory analysis, exploratory analysis in which we determined the importance of effect of crowded housing. And as we can see in zone 4 and zone 5, the effect average percent of housing crowded is more than 6%, and these are the zones where the crimes are most prevalent. Next is increase in crime during recession. As we found out a peculiar factor in our data, that during the recession period, that is from 2008 to 2012, the number of crimes increased steeply. So we recommend more patrolling during the recession phases after the economic meltdown. As we can see, in the post-recession and pre-recession phase, the number of crimes are pretty less than the recession period. Next is severeness of each drug. As we can see in our graph, that crack, heroin, and marijuana are the primary drugs used in abandoned buildings. We can recommend a further follow-up project for each of those drugs to determine their severity and how they affect the society. Next is zone-wise comparison and possible alternative use for those buildings. We recommend focusing more resources on zone 1 and zone 5 as they have higher volumes of crime per capita income. These zones have the lowest per capita income and a high amount of crime. So we recommend more community activities or educational services that may benefit the community. The next is, and the final recommendation is, the number of abandoned buildings is directly related to manufacturing durability. So it is safe that the abandoned buildings act as haven for drug exchange and not manufacturing. We have found that the method of crime that was used was possession and exchange of those drugs. So we don't recommend demolishing those buildings. Instead, it could be renovated for further activities of the city. Thank you.